All right, let's talk about ratios with surface area and volume. Now I'm actually going to take us back and we're going to start kind of combining and comparing what we've already learned about ratios. So this first problem that I have up is dealing with perimeter. If I have two similar figures and I have the perimeter of one and I don't have the perimeter of the other, we're going to find the perimeters because they're similar with our ratios. So remember, perimeter is measured in just basic units. We're measuring in centimeters, feet, inches, miles. We're not squaring, we're not cubing. So for that, we can do side over side equals perimeter over perimeter. So if I put this first little rectangle on top, it has to go on top all the way through. So I have 9 over 27 equals, well, 9 goes with the 38, so 38 over, I don't know. From there, we can cross multiply. Now remember, you can simplify before you cross multiply if you want to. So 9 can become a 1, 27 can become a 3. And then we can cross multiply. 1 times x is x. And then we have the other direction, which would be 3 times 38, which is 114. And I'll just call it units. So there's your answer with perimeter. Now, when we started looking at area, it was a little bit different because we have our sides, side over side, but what's the problem? Area becomes 15 over we don't know. However, are we using the same units? Let's say our sides are inches. Well, those are inches. So when I become an area, I now have inches squared. So if we look at these fractions, we're not comparing the same units. We're comparing these guys in inches and then these guys in inches squared. They're not the same. So remember, when we start looking at area, we have to have those units both squared. So I'm going to simplify my ratio. 2 over 6 becomes 1/3. But what's the problem? It's still not squared. And this guy's inches squared. So what do I need to do to that first fraction? I'm going to have to take that first fraction and I'm going to have to square it. So 1 squared is 1. 3 squared is 9. Now that I have everything in inches squared, now I can cross multiply to get 1 times x is x, and then 9 times 15 is 135 inches squared for the area of the second triangle. So it works very similarly with surface area and volume. When we look at surface area, what are our units for surface area? They're units squared, inches squared, centimeters squared, meters squared, which means my scale factor has to also be in units squared. So for this one, what's our scale factor? I'm going to put the second one on top this time. So we have 6 over 4, my new image over my old image. Let's simplify that. 2 can go into top and bottom, so I really have 3 halves. However, I'm talking surface area. Surface area is squared units, which means I have to square this guy. Square top and bottom. 3 squared is 9. 2 squared is 4. Now I can compare them. Well, remember, I had the second one on top. I don't know his surface area. I do know the surface area of the first one, though, is 84. And now I can cross multiply. 4 times x is 4x. Then I'm going to go the other way and do 9 times 84, which is 756. Divide each side by 4, and you get x to be 189. So you just found the surface area of the similar figures. Now volume is very similar, just a little bit different. So number 4. Number 4, I have my radius and I have my volume. We're going to use similar figures to figure this out. So again, if I figure out the scale factor, I'm going to do my new image which is the second one, so 6 over my original, which is 10. Simplify it down. 2 goes into both of those, so we have 3/5. But what's volume measured in? Volume's measured in units cubed, inches cubed, centimeters cubed, meters cubed, which means my scale factor has to also be cubed if we're talking about volume. Remember, that's not 3 times 3, that's 3 to the third, which is 3 times 3 times 3, which is 27. And then we have 5 times 5 times 5, or 5 to the third, which is 125. So that's my scale factor comparing the volumes. So I have 27 over 125. I don't know the volume of the second. I know the volume of the first is 4,188.79. Now I'm going to cross multiply. I have 125x equals 27 times 4,188.79 is 113097.33. Divide both sides by 125, and my volume for the second one comes out to be 904.78 units cubed. The other type of problem you're going to see is one like this. I tell you we have two pyramids that are similar. Okay, the volumes are 3 units cubed and 375 units cubed. I want you to find the ratio of the areas. All right, well, so volume, if I compare my volumes, I have 3 over 375. The first thing we always do with scale factors is simplify. Can I simplify this one? Yeah, I can. 3 goes into top and bottom. 3 divided by 3 is 1. 375 divided by 3 is 125. So there's my scale factor. But that's the scale factor of the volumes, which means these are units cubed. So really, we need to get down to no more cubes. What's the opposite of cubing something? Cube rooting it. So what times what times what is 1? 1. What times what times what is 125? 5. If you need a calculator for that, you're welcome to find it. So my ratio for sides, my base scale factor is 1 to 5, or 1/5. I need the ratio of the areas. Well, areas are units squared. So I'm going to take this guy and square it. 1 squared is 1. 5 squared is 25. There's the ratio of the total areas.